Good morning, students. Now we are going to continue with the chapter based on continuity. So in the last lecture I have told you about the definition of continuity of a function. Now I shall explain you once again. When do you say that the function happens to be a continuous function? Now let me consider a function given by y is equals to f of x. So let us consider the function given by y is equals to f of x. This function is said to be continuous at x is equals to c if the following conditions are satisfied. Now what are those conditions? The conditions are: first one, the function should be defined at x is equals to c. The function should be defined at y is equals to f of c. Then the second condition is that the limit of the function, that is limit of f of x as x tends to c, should exist. This happens to be the second condition. So the second condition is limit of f of x as x tends to c should exist. And the third and the foremost condition is that this limit of f of x as x tends to c should be equal to f of c. Then we say that the function happens to be a continuous function. Now by an example we shall see how to check the continuity of this function. Now let me consider first example, that is we shall consider the function which is defined by f of x is equals to 5x minus 3. We need to check the continuity of this function. We need to check the continuity of this function at the point x is equals to minus 3. We shall check whether this function is continuous at x is equals to minus 3. Now first we are going to check the first condition at x is equals to minus 3. What is f of minus 3 is equals to? At x is equals to minus 3, we will be checking what is f of minus 3 is equals to. So it is substitute x is equals to minus 3 in this. So it is 5 into minus 3 minus 3. So it is minus 15 minus 3, which is equals to minus 18. So the value of the function, right, at of the function given by f of x is equals to 5x minus 3 at x is equals to minus 3 is minus 18. Then the second one that I am going to check is the limit of this function. The second concept that I am going to check is about the limit of this function. Now limit of f of x as x tends to minus 3 will be equal to, the function is defined by 5x minus 3. So it is limit of 5x minus 3 as x tends to minus 3. So this will be 5 into minus 3 minus 3. 5 into 15 minus 3 minus 15 minus 3. So it is minus 18. Now here we see that the result number 1 and the result number 2, they are one and the same. It is minus 18. Here also it is minus 18. So here I shall conclude that since limit of f of x as x tends to minus 3 is equal to f of minus 3, the function happens to be continuous. The function is continuous at x is equals to minus 3. The function is continuous at x is equals to minus 3. Now we shall take one more example. That is 2x square minus 1. So the next function that we are going to consider is f of x is equals to. So this happens to be the second example. F of x is equals to 2x square minus 1 at x is equals to 5. This is the example. We are going to discuss the continuity of the functions at these points. So here it is f of x is equals to 2x square minus 1 at x is equals to 5. Now first condition, at x is equals to 5, f of 5 is equals to 2 into 5 square minus 1. So it is 25. 25 into 2 is 50 minus 1. So that is equals to 49. Then the second one that we will be considering, is limit of f of x as x tends to 5. Limit of f of x as x tends to 5. So this will be equal to limit of 2x square minus 1 as x tends to 5. So this will be giving you 2 into 5 square minus 1. So that is 50, right? 50 minus 1. So that is equals to 49. That is equals to 49. So here also we see that the function is continuous at x is equals to 5. This is how we check. So since, conclusion what we are going to write is, since limit of f of x as x tends to 5 is equal to f of 5. Since limit of f of x as x tends to 5 is equals to f of 5, the function happens to be continuous at x is equals to 5. The function happens to be continuous at x is equals to 5. Then the third example, discuss the continuity. Now this happens to be the third example that we are going to see is f of x is equals to mod of x at x is equals to 0. Now we are going to consider these. Now if these are the polynomial equations, then you are going to consider the examples in this manner. Now the next one is f of x is equals to mod of x at x is equals to 0. First we need to understand how is this function defined by f of x is equals to mod of x. Now you know that the definition of this function is, it is defined by x if x is greater than 0. It is defined to be 0 if x is equals to 0, and it is minus x if x is less than 0. This is the definition of the modulus function. This happens to be the definition of the modulus function. Now how is the function defined for modulus function? It is x if x is greater than 0, it is 0 if x is equals to 0, and it is minus x if x is less than 0. First condition is f of 0 is equals to mod of 0, which is equals to 0. F of 0 is equals to mod of 0, which is equals to 0. Then I need to find the limit of this function. Remember, if I want to find the limit of this function, then compulsorily I have to apply the LHL and RHL on limit only. Why? Because this happens to be a modulus function. Since this is a modulus function, I need to apply the LHL and RHL methodology only. Now I cannot directly substitute the value as x tends to 0. Since you know the condition. Last year also we have solved these types of examples, right? Last year also we have solved these types of examples. Now here let me consider limit LHL. I am solving the second part of this thing, that is limit of f of x has extends to 0. So LHL is equals to limit of f of x has extends to 0 minus limit of f of x has extends to 0 minus, right? So this will be equal to limit of mod of x, limit of mod of x has extends to 0 minus, and you know how is the function defined. It is defined by limit of minus x as extends to 0 minus. This will be equal to, now I will be, what I am going to do is I am going to substitute, or I am going to substitute x is equals to a minus h. So this is limit of minus of 0 minus h, limit of 0 minus h as h tends to 0, which is equals to limit of h as h tends to 0, which is equals to 0. This will be equal to 0, right, when I substitute. So this is what is the case. So a minus h, 0 minus h. So this is the case. So as x tends to 0 it is. So modulus 0. Then the next one that I am going to consider is, the next one that I am going to consider is limit of RHL. RHL will be equal to limit of f of x as x tends to 0 plus, which is equals to limit of what, mod of x as x tends to 0 plus, which is equals to limit of x as x tends to 0 plus, which is equals to limit of 0 plus h as h tends to 0, which is equals to limit of h as h tends to 0, which is equals to 0. Here, since, here what we see, since LHL is equals to RHL is equals to the value of the function is equals to 0. Remember, this happens to be a modulus function. Since LHL is equals to RHL is equals to f of 0 is equals to 0, the function is continuous at x is equals to 0. So the modulus function happens to be a continuous function. The modulus function happens to be a continuous function at x is equals to 0. The next definition that I am going to, or the next example that we are going to discuss is this. F of x is equals to mod of x divided by x at x is equals to 0. Which function we are going to discuss? We are going to discuss about this function. F of x is equals to mod of x divided by x at x is equals to 0. At x is equals to 0. Now, first what we are going to do is, right, we will be trying, right, at x is equals to 0. First what we will do is we will consider the LHS since this happens. Now the value of the function at x is equals to 0, right. What we are going to do is we are going to consider the value of the function at x is equals to 0. At x is equals to 0, we are going to check it. Or before that, instead of proceeding, right, at x is equals to 1, right, we are going to consider the value of this function at x is equals to 1 here. Or okay. And here we are going to put one more condition, that it will be 1 here if it is x is not equal to 0, and here it is 1 at x is equals to 0. The function takes the value x is equals to 0 here. Now it is defined in this manner: f of x is equals to mod of x divided by x if x is not equal to 0 and it is 1 at x is equals to 0. So at first condition, at x is equals to 0, f of 0 is equals to 1. This is from the given definition. Then I will be finding the limit. Limit of f of x as x tends to 0 minus is equals to limit of mod x divided by x as x tends to 0 minus. Why we take this? We take this because if x is not equal to 0 means x can be less than 0 or x can be greater than 0. X can be less than 0 or x can be greater than 0 here. X can be less than 0 or x can be greater than 0. So in this case what we do is LHL is equals to limit of f of x as x tends to 0 minus means limit of mod x by x if x is less than 0. So how is the function modulus function defined? How is the modulus function defined for mod of x if x is less than 0? It is defined by minus x. So that modulus function gets replaced by minus x by x as x tends to 0 minus. So here x and x will get cancelled. So what is left is minus 1 as x tends to 0 minus, which is equals to minus 1, because here there is no substitution, because here there are no variables. Next one is, now here we have checked what is LHL. Here we have checked what is LHL. Now RHL. RHL will be equal to limit of f of x as x tends to 0 plus, which is equals to limit of mod x by x as x tends to 0 plus, which is equals to limit of x tending to 0 plus of. Now how is the function defined for mod x if it is greater than 0? It is defined by x. So x by x. So that will be limit of x and x will get cancelled here. So what is left is 1 as x tends to 0 plus, which is equals to 1 is LHL. Now the next concept that we have to see in this type of problem is LHL equal to RHL? Is LHL is equal to RHL? No. So here, since what we conclude is, since LHL is not equal to RHL,